You know, every single time you click your mouse, swipe on your screen, or type a single letter, there's an invisible force making it all happen. Today, we're pulling back the curtain on that force, the operating system.
So let me just ask you right off the bat, what do you think is the most important program running on your computer? Is it your web browser, maybe your favorite game, or the software you use for work every day?
Well, the answer isn't any of the apps you actually see and interact with. Nope. The most important program is the massive, powerful foundation working constantly underneath it all, the one you're never even supposed to notice.
Yeah, we're talking about the ghost in the machine. So in this first part, let's really pin down what this essential program is and what in the world it actually does.
At its core, the definition is actually pretty simple. The operating system, or OS for short, is basically a translator. It's the critical go-between that lets you, a person, tell the raw, complicated hardware of your computer what to do. I mean, without it, your computer is just a really expensive, useless box of metal and plastic. A great way to think about the OS is to imagine it's like a tiny, super efficient government running your machine. First, it's a resource allocator, deciding which programs get to use the computer's brain, the CPU, and its memory. It's also a control program, kind of like a police force, stopping other programs from making errors. But most importantly, it's the government that provides the stable environment where everything else can even run in the first place. It creates order from total chaos.
But the super sophisticated OS you're using right now didn't just appear out of thin air. To really get it, we've got to go back in time, back to the early days of computing, where the biggest problem wasn't a lack of power, but just incredible, mind-numbing inefficiency.
So the very first solution they came up with was something called a batch system. An operator would literally group similar computing jobs together in a batch and then feed them to the machine, one after the other. The huge, glaring problem? The computer's powerful brain, the CPU, spent most of its time just sitting around, doing absolutely nothing, just waiting for the next job to get loaded.
So, the solution to this problem evolved in stages. We went from those slow, inefficient batch systems to a truly revolutionary idea, multi-programming. The concept was genius in its simplicity. Just keep several jobs loaded in the computer's memory all at once. That way, if one job has to wait for something, the CPU can immediately switch to another one. This idea led directly to the real breakthrough, time sharing, which is the foundation of every modern OS. It juggles tasks so fast it creates the illusion that it's doing everything at the same time.
The main thing to get here is this. By keeping all those jobs in memory, the OS can switch the CPU's attention between them constantly, thousands of times a second. It's kind of like a chess grandmaster playing dozens of games at once, never wasting a single moment. The result was a gigantic leap in efficiency. The CPU was never bored again.
Okay, so if the OS is going to juggle all these different programs at once, it has to be an absolute expert at multitasking. And to do that, it's organized into a few core departments, with each one handling a really critical job.
And here they are, the four main departments inside our OS government. It's got to manage all the active programs, which we call processes. It has to manage the system's memory. It needs to organize all of our files. And it has to control every single device plugged into the computer, from the keyboard to the printer.
First up, process management. Just think about what's happening on your computer right now. You might have a web browser open, a music player going, maybe an email client in the background. Each one of those is a process, basically a program that's actively running. The OS is the master puppeteer, creating them, pausing them, and shutting them down, all while making sure they play nicely with each other.
Next is memory management. And this is one of the most critical jobs of all. The OS acts like a meticulous librarian for your computer's RAM. It finds empty shelf space for new programs, keeps a careful record of who's using what space, and then clears that space out the second a program is finished. This is what keeps programs from accidentally stepping on each other's toes and scrambling their data.
And of course, there's file management. Here, the OS is basically your digital file clerk. It's what creates the whole folder system we're so familiar with. It handles saving, opening, and deleting files, and it remembers exactly where on the physical hard drive every single piece of data is actually stored.
All right, so now we've got all these programs sharing the computer space, sharing its memory, sharing its brain. This creates a brand new and very serious problem. How do you stop them from interfering with each other? How do you keep the whole system safe? Well, the OS has to become a bouncer.
And to be a good bouncer, the OS has to handle two very different things, protection and security. Now, they sound kind of similar, but they're not. Think of protection as an internal affair. It's about setting the rules for the programs already inside the club.
Security, on the other hand, is about defending the club from external threats. Things like viruses trying to crash the party from the outside. The OS has to do both. One of the most important kinds of protection is memory protection. I mean, just imagine the chaos if your web browser could accidentally reach into your word processor's memory and just scramble the important document you're writing. It would be a nightmare. So the OS has to build these strong digital walls around each and every process, giving each one its own private, protected workspace.
So how does it build these digital walls? It's actually a beautifully simple trick done in the hardware itself. For every single program that's running, the hardware uses two special values. The first one, called the base register, marks the starting point of that program's allowed memory, kind of like the beginning of its front yard. The second, the limit register, sets the size of that yard. And if a program ever tries to access anything outside that boundary, wham! The hardware instantly raises an alarm, and the OS steps in to shut that misbehaving program down.
And the OS has other protective measures too. It uses a built-in timer to make sure no single program can hog the CPU all to itself, ensuring everyone gets a fair turn. And it makes all direct communication with hardware, like your keyboard or hard drive, a privileged instruction. That's a fancy way of saying only the OS itself is allowed to do it. This stops a rogue program from causing some real physical havoc.
Okay, let's bring this all together. We've seen the OS as a government, as a master multitasker, and as a digital bouncer. But I think maybe the best way to think about it is as a conductor of a grand orchestra.
It's really incredible when you step back and look at it. This thing started as a pretty simple program, just trying to stop a CPU from getting bored. And over decades, it has evolved into this invisible, unbelievably complex brain that conducts a perfect symphony of hardware and software, managing every single piece of your digital world. And that leaves us with one final, kind of provocative thought. The operating system manages our photos, our private messages, our work, our finances, pretty much our entire digital lives. But as our lives become more and more digital, it really begs the question, who or what manages the OS? And that's something to think about.